Okay, now let's look at question number 47. Here it is given that question number 47 says that there is a function which is defined from R to R, and another function G which is defined again from R to R, and one more function H, and all these three functions are differentiable such that fx is equal to, so function fx is already given, x cube plus 3x plus 2, and g of fx is equal to x, which means that gx is nothing but f inverse, right? We know the property of inverse functions. That means g is equal to f inverse, and also it's given that h of g of gx is equal to, this is equal to x. This is also given in the question. So these are the three things which are given, and we need to find out the following options like g-2, h-1, h0, and h of g3. Alright, so we'll start with the first option. It's already given that g of fx, right? So let's use this. G of fx is given equal to x. Now let's differentiate this. If I differentiate, I get g dash fx multiplied by f dash x, chain rule, and this will be equal to 1. So from here I can say that g dash fx, this will be equal to nothing but 1 by f dash x. Now in this equation I can just put x equal to, I need to find out what? I need to find out g dash 2. Alright, so if I need to find out g dash 2, I will put x equal to 0, because what is f0? f0 is 2. Put x equal to 0, so I get g dash f0. Okay, here I'll get f0. f0 is nothing but 2, and this will be equal to f dash 0. So 1 by f dash 0, and what is f dash 0? fx is this, so f dash x will be 3x square plus 3. That means f dash of 0 will be equal to 3. So answer for this part will be 1 by 3. So this option is not correct. Option A is not correct. Let's check with option B. So it's given that h dash 1 we need to find out, right? So I'll differentiate this equation. Yeah, I'll differentiate this equation. H dash, actually let me just modify this equation and then I'll differentiate. So it's already given that h of g of gx, h of g of gx is given in the question. So what we can do is, here I already know that g is f inverse, right? So what's given in the question, let me take it here. H of g of gx, this is given, and this is equal to x. Alright, now what I'll do is I'll put fx both sides, right? So in this equation, put x equal to fx. I'm just replace, okay? Replace x by fx. So I'll get h of g of fx, and this will be equal to fx. Now I know that g of fx is nothing but simply x. That's already given in the question. So again I can write this term as h of g of x, and this is equal to fx. Now I can simply differentiate this. So what I'll get from here is h of gx, and this is equal to fx. Now again I can put I can replace here x with fx. If I again replace x with fx, what I'll get? F of fx, this side. I'm just replacing x by fx again. So this term will again become x. G of fx is x, it's given in the question. So hx is actually nothing but f of fx. So from here I can get the function of hx also. Now I need to find out h dash of 1. Now I know the function already, right? So I can just find out h of 1 very easily. I know that fx is equal to, I can differentiate here itself. So h dash x will come out to be f dash of fx multiplied by f dash of x. So if I use this, I need to find out h dash 1, right? So put x equal to 1. So I get h dash 1 is equal to f dash of f1. F1 will be how much? F1 will be 6 multiplied by f dash of 1. So this will be f dash of 6 multiplied by f dash of 1. So let me find out f dash of 6 and f dash 1. F dash 1 will be 3 plus 3 6, and f dash of 6, this will be 3 into 36 plus 3. So from here, if you solve this and put the values here, f dash of 1 multiplied by f dash of 6, this will come out to be 666. So that's correct option. Option B is correct. It will come out to be 666. And h of 0, we can easily find out h0 also. We know that hx is nothing but f of fx. So put x equal to 0, you will get h0. So h of 0 is nothing but f of f0. f0 is 2. So this is just equal to f2. And f2 will come out to be 16. So this option is also correct. And then we need to find out h of g3. Okay, now I already know that h of gx we found out somewhere here. H of gx is equal to fx directly. So h of g3, this is nothing but f3. So just find out f3. f3 will come out to be 3 cube plus 3 multiplied by 3 plus 2. So this will be 27 plus 6 plus plus 9 plus 2. So that's 11. So this will come out to be 38. So this is not correct. It's given 36. So correct answers would be B and C. So we can just check all the options one by one. Pretty easy question this was. Let's move further. Question number 48. Question number 48 says that there is a function which is defined from 0 to infinity to r, and this is a differentiable function such that it's given f dash of x. F dash of x is equal to 2 minus fx by x. Now this is a differential equation which is given. If I convert it to a differential equation, f dash x is dy by dx minus 2 times fx is y, and this is x. So this is a linear differential equation which is given to you guys. So dy by dx, let's get it in standard form. So this is plus 1 by x into y, and this is equal to 2. So from here, this is a linear differential equation of order 1. So we can find out integrating factor as 1 by x dx. So this will be e to the power ln x, which is nothing but x. So integrating factor is x. So what will be the solution of this differential equation? Y multiplied by x is equal to integration of 2 into x into dx. So this will be y multiplied by x is equal to x square plus c. So from here, what is the function? Y will come out to be x plus c by x. This will be the function. This is fx actually. And if this is fx, what do we need to find out? In this question, they have asked, so many options are there. We just need to check those options, and it's also given that f of 1 is not equal to 1. Achha, so if I put x equal to 1, I get 1 plus c, and this is not equal to 1. That means c is not equal to 0. So it's given in the question that c is not equal to 0. C can be anything else, but it's not 0. Now let's check all the options. So options are like this. Let us find out limit f dash. First option is f dash of 1 by x. Actually this part is not there. Okay, so we need to find out limit of f dash 1 by x. So we already know fx. So what will be f dash x? F dash x will be 1 minus cx square. This will be f dash x. X to the power minus 1, c by x square. Alright, x to the power c by x square. This is f dash x. So what will be f dash of 1 by x? F dash of 1 by x is 1 minus what, this will go upward, so I'll get this, right? And we need to find out limit of this function, limit x tending to 0 plus of 1 minus c x square. This is option A. So if I put x equal to 0, I'll simply get 1. So limit for this part will be 1. So if this is equal to 1, so this was equal to 1 actually, and this is equal to 2, right? And this is equal to 0, and yeah, this is less than equal to 2. So this option is correct. limit we are getting equal to 1. So this option is correct. And here let us find out this limit, x into f of 1 by x. So what is fx? Fx is this. So f of 1 by x will be actually 1 by x plus cx, and this multiplied by x, right? And this multiplied by x, so this will be 1 plus cx square, and this we need to find out limit for x tending to 0. So if x is tending to 0, this limit will be again 1. If this limit is 1, then this option is not correct. It's given equal to 2, right? That will not be correct. So option A is correct. Option B is not correct. X square and f dash x, again we can find out f dash x is this multiplied by x square. So I'll get x square minus c, and limit x tending to 0. Again, if limit is x tending to 0, I'll get minus c. So this limit will be equal to minus c, and it's given in the question that c is not equal to 0, so that's why this limit is not equal to 0. So this option is also not correct. And mod of fx is less than equal to 2. Now so basically we need to find out the range of this quantity, right? That fx, if mod of fx is less than equal to 2, that means fx will vary from minus 2 to 2. So it's given here that range of fx is minus 2 to 2 if x is going from 0 to 2. Achha, so let's check the function from 0 to 2. If x is equal to 0, then the function will not be defined. So let me check the limit of this function fx. Fx is x plus c by x for 0 plus. Alright, so 0 plus, this limit will be infinity, right? So graph is starting from infinity. So if I plot the graph of fx, this is 0 and this is 2, and I'll plot the graph of fx between 0 and 2 only, because option D says that we need to find out range in 0 to 2. So 0 plus, it's infinity, and yeah, 0 plus, it's infinity, right? But in the question it is given that mod of fx is less than equal to 2. That means a range should go from minus 2 to 2 only. So it should not exceed 2. Fx can never be greater than equal to 2 according to the option, but according to the function, that's not true, right? Because the function is going till infinity. Here I'll get even these values are included in the range of fx between 0 and 2. So this option is also not correct. So in this case, only correct answer was option A. Option A is the correct answer. Then let's move on to question number 49. Question number 49 says that this is alpha here. Alright, so a matrix P is given. P is equal to this matrix, and where alpha is element of R, suppose that Q is another matrix such that P into Q is equal to K into I. K is some real number and K is not equal to 0, and I is identity matrix of order 3. Alright, so it's given P into Q is equal to K into I. Now if I multiply by P inverse both sides, so if I take P inverse both sides, I'll get P inverse PQ. This is equal to K is just a constant, so I can take it outside. So pre-multiplying by P inverse. Alright, so this will become I, so that will Q into I is just Q, and this will be K times P inverse into I. So I'll get this as Q, right? This is Q. Now I know the matrix P, right? I know P. It's already given in the question that determinant of Q is equal to K square by 2, and it's also given that this element 2 3, this is minus K by 8. So let's find out this element of Q, right? Q 2 3. Okay, so if I consider matrix P is something like this: 3 minus 1 minus 2 2 0 alpha 3 minus 5. This is already given in the question. So if I try to find out P inverse, and don't find out the entire P inverse, okay, because we are just concerned about this element. So sorry, so Q is actually this Q 2 3. So we need to find out this element 2 3, so that will be this element, right? So I don't want to find out all these elements, but I want to find out this element Q 2 3. So this will be cofactor and then transpose, right? So if I find out cofactor corresponding to this element, right, minus 5, corresponding to minus 5, it will be 3 alpha and 3 alpha plus 4. 3 alpha plus 4, but there will be a minus sign because C of ij 2 plus 3 is 5, so I'll get a minus sign here. So this will be 3 minus of 3 alpha plus 4. Here I'll get minus of 3 alpha plus 4 in Q, and this multiplied by I. Alright, so this is actually P inverse. Okay, this matrix is P inverse multiplied by I and multiplied by K will give me Q. Alright, so I'm just multiplying the three matrices. So P inverse I can find out, and then here this is I, so it will be something like this. And now we can compare this element on both the sides. So if I compare on both sides, here I know that here Q23, okay, on left hand side Q23 is minus K by 8, and on right hand side it will be this multiplied by this, right? So K, and then you also need to divide by magnitude of P, right? So we also need to divide, because if we are finding P inverse, that's adjoint of P divided by mod of P, right? Determinant of P. So if I find out the determinant value of P, that will come out to be 20 plus determinant of P, that is 20 plus 12 alpha. P is already given, we can find out its determinant value 20 plus 12 alpha. So we need to divide here by 20 plus 12 alpha also. So it's something like this. If I show you the entire picture, it will be like Q matrix is there on the left hand side. Q matrix is something 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 something, but this element is known, this element is minus K by 8. Other elements we are not concerned about, but this element is known. This here I have K divided by 20 plus 12 alpha, and this into here something 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 is there. This element is minus of 3 alpha plus 4, and this multiplied by I. Now we need to compare this element on both sides. So from here I'll get minus K by 8. If these two matrices are equal, corresponding elements are also equal. So this is minus K by 8. Here I'll get this multiplied by this, right? So that's K times 20 plus 12 alpha multiplied by minus of 3 alpha plus 4. So here K will get cancelled on both sides. Minus sign will also get cancelled. So actually you will get 20 plus 12 alpha is equal to 8 times 3 alpha plus 4. So you need to solve this and find out the value of alpha. So from here I'll get 20 plus 12 alpha is equal to 24 alpha plus 32, and from here I'll get 12 alpha is equal to 20 and 32, so minus 12. So alpha is actually minus 1. So the value of alpha we already got it, that is minus 1. And now we need to find out the value of K also. So if I want to find out the value of K, what I can do is I can use determinant of this thing. See, we already know that Q is K into P inverse into I. So Q is K into P inverse into I. Now if I take determinant both sides, then magnitude of Q is equal to, if I take this K outside this determinant, it will come out as K cube, right? Because K will be multiplied 3 times. So from each column or from each row I can take out K outside. So here it will be the scalar multiplication, right? So K cube multiplied by determinant of P inverse multiplied by determinant of I. Determinant of I is 1 and determinant of P inverse. Now again we know a property that determinant of P inverse is nothing but 1 by determinant of P. If you don't know this property, simply we know this. P inverse into P is I. We can take determinant both sides. So this will be P inverse into determinant of P is equal to 1. Now I can take this to the other side. So I'll get P inverse as determinant of P inverse as 1 by determinant of P. So this thing can be written as K cube into 1 by determinant of P, and we know that determinant of P is nothing but 20 plus 12 alpha. This we already calculated, and this is determinant of I is 1. Determinant of Q is also given in the question as K square by 2. So this will be K square divided by 2. k square divided by 2. Okay, I'll solve somewhere else. K square divided by 2 is equal to k cube, and what will be this value? Alpha is -1, so this will be 8. So from here we can find out actually the value of k will come out to be 4. Now we can check all the options. So option 1, option A, is alpha is 0 and k is 8, which is not correct. This option is not correct. Then alpha is 4 alpha minus k plus 8 is equal to 0. This option will be correct. We need to calculate the other two options also. That's determinant of p into adjoint of q. Okay, we need to find out this determinant of p into adjoint of q, and so this will be nothing but determinant of p into determinant of adjoint q. And determinant of adjoint q, there is a property, we know that this is nothing but determinant of p to the power, this is 3 cross 3, right? So determinant of q powers 2, 3 minus 1, it's actually n minus 1, right? So from here we can calculate the value of this thing. So determinant of p is actually 8, right? So this will be 2 cube, and determinant of q is how much? K square by 2, so that's 4 square by 2. So again it will be 8. So this will be 8 square. So 2 power 2 power 6. So this will be 2 power 9. So this option is also correct. Option C is correct. I am getting 2 power 9. You can also find out determinant of q into adjoint p similarly, right? So determinant of q into adjoint p, I'll solve it here. Q into adjoint of p, same way this will be determinant of q into determinant of adjoint p, and this will be determinant of q, determinant of p square. So determinant of q is 8 and this is 8 square. So this will come out to be 2 power 3 and 2 power 6. This is also 2 power 9. But in option it's given this is equal to 2 power 13. So this option is wrong. So correct answer will be option B and C. For this, correct answer is B and C. So just properties of determinants you need to use in this question. Not a very tough question actually. Let's see this question, question number 50. Question 50 says that m is the smallest positive integer such that coefficient of x square in the expansion of 1 plus x whole square plus 1 plus x whole cube. So I need to find out coefficient of x square in the expansion of all this. 1 plus x whole cube and so on, 1 plus x whole power 49 plus 1 plus mx whole power 50, and it's given that m is the smallest positive integer such that coefficient of x square in the expansion of this is this, right? So this is coefficient of x square, 3n plus 1 into 51c3. So let's find out coefficient of x square. Here what will be the coefficient of x square? 2c1. Here coefficient of x square will be 3c2, and then it will be 4c2 and so on. Last one, here coefficient of x square will be 49c2, and here coefficient of x square will be 50c2 into m square, and this is equal to, this quantity is equal to 3n plus 1 multiplied by 51c3. This is given in the question, right? Coefficient of x square I am just equating on both sides. Now we need to find out, let m be the smallest positive integer. Now m is smallest positive integer, and we need to find out some positive integer n. So if I take summation of this, right, this is 2c1 plus 3c2. So what I can do is actually 3c1 plus, we know this formula, right? We know one formula, that ncr plus ncr minus 1, this is equal to n plus 1 cr, right? We know this formula, so we can use this formula actually. So instead of this, okay, here it will be 2c2, sorry, coefficient of x square will be 2c2, right? So this is 2c2 and here I have 3c2. So what we can do is 2c2 is 1, right? So instead of 2c2 I can just remove this, and instead of this I'll just write 3c3, sorry. Okay, instead of this I'll just write 3c3, because 2c2 is also 1, 3c3 is also 1. So this is chalaki that I will do, right? And this will make my life easier. Why? Because I can apply this formula now on 3c3 plus 3c2. So 3c3 plus 3c2 will come out to be 4c3. Now again this 2 I can apply the formula on again this 2. So 4c3 plus 4c2, this will be 5c3. Now next term here will be 5c2. So again this 2 will get combined, and again I'll get 6c3, and similarly it will go on till this term. So after this, so last term will come out to be 50c3 plus this term, that is 50c2. So this term I am writing as it is, and this is equal to 3n plus 1 into 51c3. Alright, so all these terms will get consumed and I will simply get 50c3. Now after this, what we can do is, this is 50c3 plus 50c2 into, so I can add 50c2 and subtract 50c2. So if I add 50c2 I will get this, and I'll subtract 50c2 also. So actually I'll write m square minus 1, right? So I'm just adding 50c2 and subtracting 50c2, because again that will make my life easier, because this will become 51c3, right? This term which is shown here. So 3n into 51c3, I can again separate this out, and plus 51c3. Now see, this 51c3 will get cancelled with this 2. 50c3 plus 50c2 is 51c3. So simply I can cancel it. So I'll get the remaining, that is 50c2 into m square minus 1 is equal to 3n times 51c3. Now what I can do is, this is 50c2. Again there is a formula, we know that this 3n multiplied by this can be written as 51 divided by 3 multiplied by 50c2. Again 50c2 will get cancelled. 51 divided by 3. So this property I am using, NCR is equal to n by r into n minus 1 c r minus 1. Both of them will get reduced by 1, and here n divided by r. Alright, so this formula I am using here. So 50c2 will get cancelled. So after this I'll get m square minus 1. This 3 will also get cancelled actually, and this is equal to 51 times n. So the final equation that I am getting from here is m square is equal to 1 plus 51 n. Now it's given in the question that m is the smallest integer, right? Smallest positive integer is m. So the minimum value of m square, so what will be the minimum value of m square? If m is the smallest positive integer, then this also should be minimum. So this will be minimum only when n is equal to, so this right hand side, see, this is a perfect square. So if this is a perfect square, this left hand side should also be a perfect square. So the for what value of n I will get first perfect square, so you need to check it by hit and trial, you can check it, right? So n equal to 0, that will not come. Then n is actually positive, right? So n can't be 0. It's given in the question that n is positive for some positive integer n, right? So n cannot be 0, otherwise n equal to 0 would have been answer. So n can be 1, 2, 3, 4, 5. So for n equal to 5 I'll get this as perfect square. So in that case m will be minimum. So n equal to 5 will be the right answer for this question. N equal to 5. Okay, then here we have a question from determinants, total number of distinct x. So we just need to solve this equation. Here see, I can take x common from here, I can take x square common from here. So actually x cube will come out common, and I'll get 1, 2, 3. Here I'll get 1, 4, 9, and I'll get 1 plus x cube, 1 plus 8x cube, and 1 plus 27x cube. and this determinant, this is equal to 10. Now I can split this determinant actually into two determinants, right? So this determinant I can split it. So x cube, this entire thing multiplied by 1, 2, 3, 1, 4, 9, and first I'll consider only this, that is 1, 1, 1 plus another determinant, that's 1, 2, 3, 1, 4, 9, and here I'll get x cube, 8 x cube, and 27 x cube. So in the second part I'll take this three values. So here again I can take x cube common and equate this to 10. Alright, so if I take x cube common, I'll get x cube into this determinant 1, 2, 3. I can simply find out the value of this determinant. It's a very easy determinant to solve. And here again x cube common and this x cube, so it will become x power 6 multiplied by 1, 2, 3, 1, 4, 9 and 1, 8, 27, and this is equal to 10. Now we can simply find out the values of these two determinants and then we can solve the equation which is there. So if I solve and find out the value, this determinant will come out to be 2, so I'll get 2x cube, and the value of this determinant will come out to be 12, so 12 x power 6 is equal to 10. I'll get this equation. So actually your equation is something like this. You can see it's quadratic in x cube whole square plus 2x cube minus 10 is equal to 0. So if I factorize this, I'll get 6x cube minus 5 and x cube plus 1 and multiplied by 2. This way I can factorize this. So 2 will simply get cancelled, it will go to the other side. So from here I'll get actually two solutions, that x cube is either equal to 5 by 6 or x cube is equal to minus 1. So x is equal to minus 1 from here, and from here I'll get another solution, that x is equal to cube root of 5 by 6 and minus 1. So in all there are two solutions. Both the solutions will satisfy this equation. So in all there are two solutions. So total number of distinct values of x, that will be 2. How many values of x are there? 2 values of x are there. One is minus 1 and other one is 5 by 6, cube root of 5 by 6. So 2 solutions I'll get. Again an easy question from determinants. Okay, let's come to question number 52. I'll zoom into this question first. Yeah, so this is the question. Z is this. Actually this is omega only. If you see carefully, this is nothing but z is omega. Alright, omega you know, cube root of unity. Iota is equal to square root of minus 1. R and S are element of 1, 2, 3. So R and S are some numbers from 1, 2 and 3. So we need to pick the values of R and S from either 1, either 2 or 3. Now P is a matrix, a 2 cross 2 matrix, that's equal to minus Z power R, Z power 2S, Z power 2S and Z power R. This is, and I is identity matrix of order 2. So I is nothing but 1, 1 and 0, 0. Now total number of ordered pairs R comma S for which P square is equal to minus iota, minus I, identity matrix, right? So P square, let's find out P square. P square will be something like this. We need to multiply this matrix twice. So P square will be, and Z is equal to omega, right? So I'll just simply put the value of Z as omega so that life becomes easier. Minus omega power R, omega power 2S. Here also I'll write omega power 2S. Here I'll write omega power R. This multiplied by again the same matrix, omega power R, omega power 2S, omega power 2S and omega power R. If I multiply this two matrix, and this is equal to minus I, so that's minus 1, 0, 0. Now P square, so this, if I multiply this two, what will I get? I need to multiply this with this, so I'll get minus omega power 2R. So minus sign will go away actually, so I can just write omega power 2R plus omega power 4s. Here I'll get omega power minus 1 power r, I can take common. So minus 1 power r into omega to the power 2s minus 2s plus r, actually 2s plus r plus omega to the power r plus 2s. Here I'll get this, and here I'll again get the same element, that's minus 1 power r multiplied by omega power 2s plus r plus omega to the power r plus 2s. And here I'll get this element omega power 2s plus omega power 4s. So actually we can see these two elements are same and these two elements are same. So, and this is equal to minus I. So if this is equal to minus I, either this should be equal to 0 or this should be equal to both of them, right? So this should be equal to 0 and this should be equal to minus 1. So I'll just equate the respective elements, right? So minus 1 to the power r and omega power 2s plus r plus omega to the power r plus 2s, this is equal to 0, right? And another equation is omega power 2r plus omega power 4s, this should be equal to minus 1. Now we need to solve and find out how many ordered pairs are possible if we need to pick r and s from 1, 2 and 3. So r and s can be either 1 or 2 or 3. So how many values of r and s are there such that this equation holds true, right? So what I can actually do is see this two are same, so I can just take omega to the power r plus 2s common from here, right? So if I take omega to the power r plus 2s common, okay, or 2s plus r, this is also 2s plus r, this is also 2s plus r, so I'll take it common. So what will remain? Minus 1 to the power r plus 1, this quantity will remain, right? And this is equal to 0. Now see, this is a non-zero quantity, right? That's omega power something, and omega is a complex number, so omega power anything will never be 0, right? Omega power 1, 2, 3, anything will never be 0. So this is a non-zero quantity, so if there is something which becomes 0, then it will be this. Alright, so what are the values of r which are possible? So from here we can clearly see that r will be something odd. If r is equal to 2, this will never be 0. So r will be either 1 or r will be 3. R cannot be equal to 2, right? Why? Because if r is even, then this quantity will become 1 plus 1 2 and it will never be 0. Alright, so r can be only two values, either 1 or 3. So there are two cases only. So first case is, let's consider the first case, that r is equal to 1, and then let's try to find out the values of s. What are the possibilities? So if r is equal to 1, this equation, look at this equation, this will become omega square plus omega power 4s is equal to minus 1. Alright, so this is nothing but omega power 4s is equal to minus times 1 plus omega square. So, and we know that 1 plus omega square is 0. So 1 plus omega square will be minus omega, so this will come out to be omega. So what can be the values of s? So from here I can write this, and omega is perfectly equal to omega power 4, right? So I can simply say that s will be equal to 1, right? So from here I can say that I'll get s equal to 1, then only this will be equal to omega, right? So if r is 1, s is 1, that is one ordered pair that we got. Case 2 is if r is equal to 3. If r is equal to 3, I'll get omega to the power 2r, right? So that's 6 plus omega power 4s is equal to minus 1. Now omega power 6 is 1, so omega power 4s is equal to minus 2, and omega power 4s, actually it will never be equal to minus 2, right? So from here I'll get no solution. Why? Because we simply know that omega power 1 is omega, omega power 2 is omega power 2, omega power 3 is 1, and then the cycle repeats, right? Omega power 4 is again omega, omega power 5 is omega square, omega power 6 is 1. So omega power anything will be either omega or omega square or 1. but it will never be equal to minus 2. Minus 2 will never get, right? So this is never equal to minus 2. So from here I'll get no solutions. And if this is no solution, that means I have only one ordered pair, that is 1 comma 1. So there is only one ordered pair which will satisfy this, that's 1 comma 1. So answer for this question 1. 1 comma 1, there is only one ordered pair. Question asked in here was total number of ordered pairs, so your answer would be 1. Okay, question number 7, based on integration. It says that total number of distinct x, which is element of x is somewhere between 0 and 1, and for which integration of 0 to x t square plus 1 plus t power 4 is dt is equal to 2x minus 1. Now we all have studied Lebanese rule, right? So if you have studied Lebanese rule, you might be knowing that Lebanese rule is actually differentiation of an integration, right? So derivative of antiderivative. So derivative of antiderivative rule says that if I differentiate this both sides, so I put the value of put t equal to x, right? So I'll get this as the differentiation, right? And this is equal to 2, right? If I differentiate both sides, I'll get this equal to 2. Now let me consider a function, right? Let me say that this LHS, what is written on the left hand side, this is fx, suppose. So 0 to x, and then I'll try to analyze this function, right? This function is fx. Okay, so LHS is fx and RHS is, let me consider this as gx. Okay, so this is 2x minus 1. So there are two functions actually, fx and gx. Now I need to find out the total number of intersection points in the graph, right? So actually if I want to find out total number of distinct solutions, that means I can find out total number of intersection points. The number of intersection points in graph will be the number of solutions. So I can easily plot this straight line. And how to plot graph of this function, that's actually a little tricky. So tell me what will be the value of f0. F0 will be, if I put x equal to 0, I'll get integration from 0 to 0, and that will be 0, right? So f0 is 0, and so I need to plot the graph of both the functions between 0 and 1 only, because I am only I need to find out total number of distinct solutions between 0 and 1 only. So I am only concerned about this interval, no other interval. So I'll simply plot graph of both the functions in 0 and 1, and then try to find out the total number of intersection points. Okay, so gx we can easily plot it. How to plot fx? f0 is 0. Alright, now let's find out the value of this function at x equal to 1. See, f dash x, what is f dash x? This is f dash x. F dash x is this quantity, and this quantity will always be positive. It is a positive quantity, right? So this function is increasing. If f dash x is positive, I can say that function is increasing. So f0 is 0. So f1 will be, it's an increasing function, so something greater than 0. Now f1, right? So if I plot the graph of this, it will be something like this. f0 is 0. At x equal to 0, value of the function is 0, and at x equal to 1, value of the function will be something, and I'll get an increasing graph, right? So graph will increase something like this. So f1 is nothing but 0 to 1, 0 to 1 t square 1 plus t power 4 dt. Alright, this is f1, and if I try to find out the value of this function f1, then what can I say about this? Actually, we know that this quantity, right, t square divided by 1 plus t power 4, 1 plus t power 4, this quantity will always be between 0 and 1 only, right? This quantity will always be between 0 and 1 only. It will always be less than 1. It will always be less than 1 because we know this thing, right, that if I look at this quantity like this, t square divided by if I take this t square to the denominator, okay, so I'll get 1 by t square plus t square. Now t square is a positive quantity, so if I know this property, right? Like 1 by t square plus t square, this will always be greater than equal to 2. Why? Because that is from am greater than equal to gm. Like am will be am of these two numbers, right? So arithmetic mean of 1 by t square plus t square divided by 2, this will be equal to geometric mean. Geometric mean of these two numbers will be simply 1 by t square multiplied by t square. So that's 1, and to the power 1 by 2, so that's again 1. So this quantity will be actually greater than equal to 2. So if the denominator is greater than 2, then this quantity, right, 1 by, so this will be 1 by some quantity which is greater than 2. 1 divided by some quantity which is greater than 2, so that this quantity will be always less than 1 only. 1 by 2, 1 by 3, 1 by 10, 1 by 11, 1 by 12, all of them are less than 1. So this quantity is always between 0 and 1, this much we know. Now if I integrate both sides, in this you can integrate both sides, integrate everywhere, because it's an increasing function, so no, we can directly integrate with respect to dt, you can integrate. So this thing will be between 0, and this is nothing but this is 0 to x, right? We can integrate 0 to x, so this will be between 0 to 1, actually 0 to 1, 0 to 1 and 0 to 1. So this is f1, and this quantity will be 1 dt from 0 to 1. So 1 dt from 0 to 1 is nothing but 1 only, right? So f1 is between somewhere between 0 and 1, but it is less than 1. Right now we have successfully proved that f1 is some quantity which is less than 1. So this is 1, and suppose this point is 1. Okay, so f1 is some quantity which is less than 1. So let's assume that this is f1. Okay, let me assume that f1 is this. So graph of this function, graph of fx, will be something like this, right? Graph of fx will be something like this, and f1 is less than 1 here, remember this. And now let me plot the graph of other function, that is 2x minus 1. 2x minus 1. So at x equal to 0, value of the function is minus 1, so it will be somewhere downwards here, somewhere here, minus 1. And at x equal to 1, value of the function is 1, so here, right? So the graph of this straight line will be something like this. Okay, and at x equal to 1, so g of 0 is minus 1, and g of 1 is actually g of 1 is 1, right? So g of 1 is equal to 1, but f of 1 is less than 1. So this graph will surely intersect at one point. Both the graphs, they will surely intersect at one point. If suppose f of 1 was greater than 1, then in that case we are not sure, because in that case graph can be like this also. But here we know that f of 1 is actually less than 1, right? So it will be somewhere here or here or here. So graph will be, it will intersect this line at least one point, right? So one point it will definitely intersect, and it graph is increasing, so it will definitely intersect gx at one point. So total number of distinct values of x, we can simply see from here that it's 1, right? So you just need to plot the graph of both the sides and then interpret the number of intersection points. This is what we needed to do in this question. So this was a good question, interesting question this time. Okay, and 54th, this question was a very easy question. Question from limits are generally very easy. X square sine of beta x divided by alpha x minus sine x. So what we can do here is we can simply divide by beta x and multiply by beta x. So this quantity will become 1, sine beta x divided by beta x. So this will simply become 1. So what else we can say from here? We need to find out the value of, and this quantity, this is equal to 1, right? This limit is equal to 1. So we need to find out the value of 6 alpha plus beta. 6 times alpha plus beta. We need to find out the value of this. So basically I got beta into x cube divided by alpha x minus sine x. So I can use L'Hopital. Actually it's 0 by 0 form, so we can just differentiate the numerator and denominator. So here I'll get nothing but 3 times beta into x square, this divided by alpha, minus differentiation of sin x is cos x. So from here, and this is limit x tending to 0. This limit is given in the question equal to 1, right? Now this limit should be equal to 1. Now see, if I see this very carefully, this limit is coming out to be 0, right? The limit is coming out to be 0. Why? Because if x is tending to 0, I'll get 3 beta multiplied by 0 divided by alpha minus cos 0 is 1, right? So simply I'm getting this. So this limit is coming out to be 0, but I want this limit to become 1, right? This limit exists. If this limit is equal to 1, that means this limit exists and it is equal to 1. So it's not possible until and unless alpha is equal to 1, right? If alpha is equal to 1, then only I will get 0 by 0 form. Numerator I already have 0. If alpha is equal to 1, then in that case again this will become 0 by 0 form, and in that case maybe the limit comes out to be 1. That case maybe the limit exists, right? So that means alpha is simply 1. Alpha has to be 1, otherwise things will go wrong, right? Otherwise it will not come out to be 1. So alpha is definitely 1. So now we need to simplify this. 3 beta x square divided by alpha minus 1, and sorry, this is 1 minus cos x, not alpha minus 1. Alpha is 1 minus cos x, and limit extending to 0. Now if I take this x squared to the denominator, I know this form, right? 1 minus cos x by x square, and this limit is 1 by 2. This is a standard form, all of us know this. So this is equal to 6 beta, and 6 beta is equal to 1. It's given in the question, so beta is equal to 1 by 6. So alpha is 1, beta is 1 by 6. We need to find out the value of 6 times alpha plus beta. So that's 6 times 1 plus 1 by 6. This will come out to be 6 plus 1. So 7 will be the answer. So very easy question from limits. Answer is 7. Answer for this question is 7. So I hope this solutions of JEE Advanced 2016 Maths Paper 1 will be useful to you guys. Those who are preparing for JEE in future, those who are planning to give JEE in 2017 or maybe years to come, for them also this will be useful. So I hope you understood all the questions in the solution. If you have any doubt regarding any of the question or any of the solution, you may post it to us, you may write it to us on our forum. Alright, so I'll take a leave. Goodbye, good night, take care.